welcome to True Projects. In this video, we are going to discuss about the project which is false positive reduction on lung nodules detection in chest radiographs by Ensemble of Convolutional Neural Networks. So before getting into the execution, let me give you an overview of the project. So what are these lung nodules? Lung nodules, they are nothing but they are just the small growths that can be found in lungs when doctors examine them using image tests like X-rays or CT scans. And these lung nodules, they can be either harmless or they can be a sign of serious conditions like lung cancer. So, when doctors discover these nodules, they need to figure out if they are harmless or potentially cancerous. So, moving on to this chest radiographs, which are chest X-rays, they are commonly used to look for these nodules, which are lung nodules. But sometimes the traditional methods used to find them can make mistakes identifying normal parts of the lungs as nodules, which we call as false positives. So we call them as false positives. This can cause unnecessary worry for both the doctors and patients and may lead to additional tests or treatments that aren't needed. So, improving how we find these nodules in X rays is really important. It helps doctors making better decisions about whether further tests or treatments are necessary, which means patients get the right care without going through extra stress or procedures they don't need. So, what are we going to do in this project is we are going to develop an efficient system that will detect these lung nodules and identify whether there is disease or not. So, the author in the base paper to enhance lung nodule detection in chest radiographs, he has used a technique called ECNN, which is nothing but it is ensemble of convolutional neural networks. It employs the unsharp mask technique to amplify nodule signals and selects the patches from the images. By combining results from three optimized CNNs and applying a logical AND operator, ECNNs effectively decrease false positives and boost sensitivity in detecting lung nodules in chest X-rays. So, to further improve the performance, we have proposed a technique called exception and densenet. So, these models are used for classifying lung nodules from chest radiographs. After thorough evaluation, we have discovered that exception model demonstrated significantly higher accuracy in this task. Integrating advanced models like exception alongside ECNNs, ensembles provide a comprehensive strategy to enhance both accuracy and efficiency of lung nodule detection in chest X-rays. So, moving on to the workflow, first we have imported lung chest X-ray nodule dataset and then we have explored it. After importing and exploring, we pre-process the images using techniques called rescaling, shear transformation, zooming, horizontal flipping, and reshaping using some image data generator technique. After that, we built several models that are ResNet 50, VGG16, Exception, DenseNet 201, and MRFLNet on the pre-processed data. Once these models are trained, then we have saved them for later use. So from all these algorithms as exception performed well, so we have used it and deployed it in the front end. So for developing the front end, we have used Flask framework with SQLite. And then we have deployed this exception model in the front end. So moving on to the software and hardware requirements, we need software requirements as well as hardware requirements to implement the project. So in software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3. Front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. And moving on to the hardware requirements, we need Windows operating system, i5 and above processor, 8 GB and above RAM, 25 GB and above hard disk. So these are the algorithms built in the project. So among all the algorithms built, exception which we have proposed, it has performed well. So let's understand what is this exception. Exception is a deep learning technique and it is known for being good at understanding images. It does this by breaking down the process of looking at images into two main steps. The first step is to look at different parts of the images separately. This is called depth-wise convolution. Then it combines these parts to understand how they relate to each other. This is called point-wise convolution. This helps exception to understand images better and pick up important details. One of its strengths is that it is really efficient at doing this, which is important when you are dealing with lots of images like medical analysis. Plus, it is great at figuring out what features in the images are important for making classifications. And another important thing about exception is that it can learn from other datasets before being used for a specific task, and it is also known as transfer learning. This makes it super adaptable, useful for projects like detecting lung nodules. So, this exception is used for deploying the project. Now we will execute the project. To execute it, first we have to open the code folder. So, these are the source code files in the code folder. So, let's understand these files. Each file, how will it be used in the project? So, here in the first folder, we have the dataset used in the project. So, these are multiple classes in the dataset. Coming to the first folder, we have the class of just changes. So these are the images related to just changes. It is nothing but anything unusual in the chest. So these are the images related to unusual in the chest. So now get back. In the next folder, we have degenerative infectious diseases. So these images are related to degenerative infectious diseases. Here, the changes are caused by infections breaking down tissues. So now get back. Moving on to the next folder, which is encapsulated lesions. Here we have the images related to encapsulated lesions. Encapsulated lesions are nothing but they are abnormal growths wrapped in a protective covering. So these are the images related to encapsulated lesions. Get back. Here in the next folder, we have the images related to high density. Higher density images are nothing but areas that look denser than normal. So in each image, we'll have areas that look denser than normal. So now get back. The next folder is inflammatory processes folder. So here we have the images related to that. It is the sign of inflammation in the chest. So now get back. In the next folder, we have lower density related images. Lower density is nothing but areas that look less dense than normal. Get back. In the next folder, we have mediastinal changes. So here we have images related to mediastinal changes. So these are the changes in the middle part of the chest. So these images are related to changes in the middle part of the chest. Now get back. Here we have normal, where everything looks as it should. So there are no problems. So these images are normal images. So get back. In the last folder, we have obstructive pulmonary diseases class. So it is the condition blocking airways in the lungs. So these images are related to obstructive pulmonary disease. Now get back. So we'll be using all these images in the project. So in the code, first we load all the images and then we split the data into train and test that we store it in the output folder. So here in the output folder, we have the data set as train and validation. So we'll be using training set to train all the algorithms and validation set to evaluate all the algorithms. So here we can see all the different classes are available. So now get back. Here in the sample folder, we have all the different classes. So we'll be using all these images to test it in the front end to detect the lung nodules disease. So now get back. Moving on to the next folder, which is static folder. In this folder, we will have CSS, JavaScript, and Bootstrap files. These files, they are important for project styling as well as interactivity. The next folder is templates folder. Here lies all the HTML pages used in the project. They are index.html, about.html, etc. And each HTML file represents a different page of the website and provides structure and layout for displaying content to the users. The next file is app.py file. This Python file encompasses the front-end logic of the project. It handles server-side operations, including processing user requests, interacting with the database, and dynamically generating content to be presented in HTML templates. In the next file, which is model file, this file contains the information about all the algorithms used in the project, and it will be loaded into the project code during runtime. Moving on to the next file, which is notebook.ipynb. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. Here in the last file, which is signup.db file, it is a database file. It is used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the command cd followed by the space, we need to paste the copied path and then click on enter. So here we can observe that current directory is changed to the code folder's path. So with the command cd, current directory will change to the code folder's path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. This command, it will execute Python script and it will perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. So this is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. Here we need to paste the link and then click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So first we need to sign up. So click on sign up and enter all the registration details if we are registering newly. I have already registered, so I will directly sign in. So click here. Here we need to provide username and the password to sign up. So I have provided my username and the password. Now click on login. We have signed in successfully and we are redirected to classification page. So here we can see a choose file button. We need to click on that for uploading the just X-ray images. So click on choose file. I already told you that we'll be uploading images from the sample folder in which we have test cases. So here are the all different class test cases. So from the first folder, which is just changes, we'll be uploading image from it and see how will it correctly classify as just changes or not. So I'm going to upload this image. Click on open. Here we can observe that image is loaded. Now click on upload. So here we got the prediction for the uploaded chest X-ray image. It has predicted as the patient is diagnosed with chest changes. So here we can observe that application has correctly detected it as chest changes. So that may be of atelectasis, malformations, agenesis, and hypoplasia. So now we will upload some more images from the same folder. So click on classification, click on choose file. So this time we'll be uploading the last image. Click on open. So now click on upload. So this time also it has correctly classified as it has just changes. So now we will try uploading from the other class folder. So click on classification, click on choose file. So go to sample. This time we'll upload from degenerative infectious diseases folder. So I'll be uploading the first image. Click on open. Image is loaded now, uploaded. So this is the uploaded X-ray image. For this, we got the prediction as the patient is diagnosed with degenerative infectious disease and it has correctly classified as degenerative infectious disease. So it may be of tuberculosis, sarcoidosis, proteinosis, fibrosis. So degenerative infectious disease may be of these types. So now we will try uploading some more lung nodule images. So click on classification, click on choose file. This time we'll be uploading this image. Click on open. So here we got the prediction for the uploaded chest X-ray as degenerative infectious disease is diagnosed for that particular patient. So we will try uploading some more images. So click on classification, click on choose file. This time we'll be uploading from the other class folder. So we'll be uploading from encapsulated lesions. I'll be uploading this image. So for the uploaded X-ray image, here we got the prediction as the patient is diagnosed with encapsulated lesions, and they are of abscesses, nodules, cyst, tumor masses, and metastases. So this encapsulated lesions may be of these types. So now we will try uploading some more images. Click on classification. Click on choose file. This time we'll be uploading images from the other folder. So I'm going to upload from higher density folder. I'll upload this image. So this is the uploaded chest X-ray image. Here we got the prediction as the patient is diagnosed with higher density. It may be of pleural effusion, atelectatic consolidation, hydrothorax, and emphymia. So this higher density may be of these types. Now we will upload some more images. Click on try again. Click on choose file. This time we'll be uploading the last image and now upload it. So this is the uploaded chest X-ray image. Here we got the prediction as the patient is diagnosed with higher density, and these are the types of higher density. So now we will try uploading some more images from the other folder. So click on try again. Click on choose file. This time we'll be uploading from inflammatory process folder. So I'll be uploading this image. And now click on upload. So this is the uploaded image. And here we got the prediction as the patient is diagnosed with inflammatory process, which is pneumonia. We'll try uploading some more images from the same folder. So click on try again. Click on choose file. This time we will upload this image. So this is the uploaded image. And here we got the prediction as the patient is diagnosed with inflammatory process. So now we will try uploading from the other classes folders. So click on classification. Click on choose file. So this time we'll be uploading from lower density. I'll upload this image. So here we got the prediction as the patient is diagnosed with lower density. It has correctly classified as lower density, and it may be of pneumothorax, pneumodistatinum, and pneumoperitoneum. So now we will try uploading some more images. Click on try again. We will move on to the other folder, which is mediastinal changes. So I'm uploading this image. So here we can observe that the patient is diagnosed with mediastinal changes, and these may be of mediastinal changes diseases. So we'll try uploading some more images. Click on try again. So click on choose file. I'll be uploading this image. So here also we got the same prediction as the patient is diagnosed with mediastinal changes. So now we will upload from some other classes. So click on try again. So we will upload from the normal folder in which we have no disease. So I'm uploading this image and now upload it. So here we got the prediction as the patient is diagnosed with normal. He has no disease related to lungs. We'll upload some more images from the same folder. Click on choose file. I'm uploading the last image. So here we got the prediction correctly as the patient is diagnosed with normal. So now we will try uploading images from the last class folder. Click on choose file. Click on sample. I'm going to upload from obstructive pulmonary diseases folder. So I'll be uploading this image. Click on upload. So here we got the prediction for the uploaded chest X-ray image as the patient is diagnosed with obstructive pulmonary disease, and they may be of emphysema, bronchopneumonia, bronchitis, embolism. So these are the different type of obstructive pulmonary diseases. We will try uploading some more images from the same folder. Click on try again. Now we will upload this image. So here we got the prediction for the uploaded image as the patient is diagnosed with obstructive pulmonary disease. So we have tested from all the classes of sample folder. So now we will see the graphs of the project. So click on graph. So here we have loss in accuracy curve of exception. So here on x-axis we have iteration and on y-axis we have loss. We can observe that for every increase in the iteration, loss is being decreased. So moving on to the accuracy curve graph of exception. Here on x-axis we have iterations and on y-axis we have accuracy. So for every increase in the iteration, that is epoch, accuracy is being increased. So here we can observe that accuracy is being increased. And here blue color represents training accuracy and orange color represents validation accuracy. So moving on, this is accuracy score comparison graph on which x-axis represents accuracy score of each algorithm and on y-axis we have all the algorithm names. From all the algorithms, exception is performing well. So here we can observe that it has got the highest accuracy. And this is precision score comparison graph. Here we have recall comparison graph. And this is FN score comparison graph. Now click on sign out. So in this way, just by uploading pictures to the system that are chest X-ray images, we will get the detection whether it is of which disease. So the project showcased the efficiency of incorporating the exception model alongside other deep learning architectures to achieve superior accuracy in lung nodule detection from chest radiographs. The utilization of exception contributed significantly to the overall performance enhancement, underscoring its pivotal role in advancing the diagnostic capabilities of the developed system.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.